Yeah, so hello everyone. My name is Balam Mugisha and I'll be taking you through cache memory mapping functions and replacement algorithms. So let's dive into it. Let's start with cache memory mapping functions. We actually have three techniques, which are direct mapping, associative mapping, and set associative mapping. We'll actually break all of them down. Let's start with direct mapping. So over here is direct mapping, and this is our main memory divided into blocks. Yeah, this is block 0, block 1. Yeah, so this is actually our block length from here to here, and we will actually realize that our block length is actually equal to our length of the cache line. So over here is our cache memory divided into lines. As this is line 0, line 1 up to line m-1, which is actually our last line. Yeah, so this is a tag over here. So what happens is one a one block of main memory is actually mapped to exactly one line of cache memory, as we are seeing over here. Yeah, so this happens for the rest of the blocks and their lines respectively. Yeah, so let's go to associative mapping. So for associative mapping, it's actually a different case because we actually see one block of main memory being mapped to any line of cache memory, as you can see over here. Yeah, so one block of main memory is actually being mapped to any line of cache memory without any restrictions. Yeah, that's the difference between associative mapping and direct mapping. For direct mapping, a block of main memory is mapped to exactly one line of cache memory, but for associative mapping, one block of main memory can be mapped to any line of cache memory. So let's try to see the third technique, which is set associative mapping. So for set associative mapping, uh, it's a different case now. So we actually see uh, lines of cache memory being grouped into sets. So say the first two lines of cache memory are grouped into the first set, which is set 0. So what happens is now this time around block 0 will be mapped to a set. We actually saw two lines of cache memory being grouped into a set. So what happens, block 0 will be mapped into a set, but what happens is block 0 will be not restricted to any line of that particular set. So block 0 can be mapped to either line 1 of set 0 or line 0 of set 0. Basically that's what set associative mapping is. It actually combines advantages of associative mapping and direct mapping like we saw earlier. So let's go to the next thing I was supposed to talk about, which is replacement algorithms. So what happens is when the cache memory is full, you need algorithms to help you add other things in the cache memory or add other blocks in the cache memory. So we actually have three common techniques that I used. First of the first one will be least recently used. So say we have these three blocks. We have block B, block C, and block A. And say we had a new input coming in, a new block D coming in. So what happens is A is taken in front since it is the most accessed, and B is taken at the back and replaced by the new letter D. So B is the one which is actually least recently used. So it's actually taken at the back, and then D has to come in as a new input or as the new block. So the next one we have first in first out as a replacement algorithm. So for first in first out, as we can see, these are blocks. So what happens is B is the one that came in first. So you see it's at the back, so it will be B that will be evicted or replaced. Say we had a new input F. Yeah, so F will actually come in and B is moving out. I think we notice the difference between this and this thing over here. So our third common replacement algorithm is least frequently used. So for least frequently used, they actually consider counts. how many times has your block been accessed, or has a single block been accessed. So as we're seeing here, block A has been accessed 2 times, block B has been accessed 1 time, and block C has been accessed 3 times. So let's say we wanted to bring in a new block D. So B will be removed. As you can see, it has the least counts for D. As you can see, D is now in and B is out. So in conclusion, I would say these mapping functions and replacement algorithms work together to optimize cache performance by reducing the time it takes to access frequently use database to access patterns of programs running on the processor, and the choice of which to use depends on the specific requirements and constraints of the system. I hope this was helpful. That's it from me. I guess it was a good day.